All right, today we're going to start Chapter 10, and Chapter 10 is about counting strategies, ways of counting things. And what we're going to do today is something called counting by systematic listing. And we're going to start with an example. So we're going to consider a group of students, Abigail, Bailey, Nate, David, Elias, and Macy. And we're going to list the different ways of forming the following groups. So we've got a group on part A, or for problem number 1, that we're creating a president and a treasurer, and they're different sexes. So we've got one boy and we've got one girl in our grouping. And it matters whether or not you're the president or the treasurer, because of course they would have different roles if they were doing some kind of operations or something. So it will make a difference which of those situations we're in. Sometimes it matters and sometimes it doesn't. And I'll show you an example in a minute where it doesn't matter. So we're going to simply list out all the ways that this can happen. And I chose the names strategically so that they're all different first letters so that we don't have to write them all out. We can just use their first letter as an initial, because otherwise it's going to just take too long. So we've got Abigail, Bailey, Nate, David, Elias, and Macy. Okay? So here are our letters. And we need to create ways of having a president and treasurer. And just because they're listed in this order, we're going to list the president first and the treasurer second. Does that make sense? All right, so who is the first president candidate? Hey, Abigail. She's just listed first, right? So we can do Abigail. But then we have to group her with someone who's a boy, right? Because Abigail's a girl, we've got to group some with a boy. So we're just going to go down the list. We're going to try to keep as like orderly as we can so we don't miss one, because it's really easy to miss one if we start bouncing around. So the first boy that's listed would be Nate. Whoops. Nate. So A-N, you don't necessarily have to put a comma between them. I don't know exactly why I did. We'll just take that out right now. So A and then N. But it doesn't have to be Abigail and Nate. It could be Abigail and David, or it could be Abigail and Elias. Right? Those are all the combinations where Abigail's president. Any other combination would put her with a girl, and it's just wanting it to be not that way, right? So I'm going to have a boy and a girl, and that would be this one. Okay, so this is one option. But maybe I don't have Abigail for president. Maybe instead I have Bailey for president. And so if I put Bailey as president, who are the people that she could be working alongside? Nate, David, Elias. So it looks much the same, correct? Okay. But then maybe I don't have Bailey as president. Maybe I have Macy. She's our last young lady. So Macy with Nate, Macy with David. Macy with David, or Macy with Elias. Okay, this is all the combinations that have a girl as the president, right? But it didn't say that it had to be that way, correct? I could take every single one of these and flip them around. That'd be one way to make sure I capture everything. Or I can simply go back and I can do the boys one at a time like I did the girls one at a time. That's how I'm going to do it, but it doesn't matter. So I could instead just go down my list, go with Nate as the president. And Nate has to be grouped with each one of the young ladies. So Nate with Abby, Bailey, or Macy. And I can do the same thing with David, right? David with Abby, David with Bailey, or David with Macy. And then also Elias. Elias with Abby, Bailey, and Macy. Now, it didn't ask us how many there are, but you could count these, right? Count these results. How many results did we end up having different combinations of people? 18. There are 18 of these here. I'm making mention of it because we're going to take a look a little bit later at how we could figure out how many without actually writing them all down too. So this writing them all down was not too bad. There's only 18 things that I had to write down, right? But if the group had been much bigger, then it would have been much more, right? And we probably wouldn't have wanted to write that down very much. So we're going to change the scenario just a little bit. We're going to create a scenario where we have 3 people we're picking. It's the same characters, right? The A, B, N, D, all that stuff is the same at the beginning. But we have a president, a secretary, and a treasurer. And the categories, so I've got 3 that I'm listing. The categories are such that the president and treasurer are the women. Okay? So over here, once I finished listing all of my girls first, I paused and I said, well, it didn't say I had to have the girls first, right? But on this one, it actually does. It says that the girls are the only candidates for president and treasurer. And it doesn't say that the girls couldn't be secretary. Did you notice that? It didn't say it has to be a boy for secretary. So we want to keep that in mind as well. So I'm going to list them in the same way that I did before. So I'm going to list them in the order that they're given. So president first, secretary second, and treasurer third, just because of the order that's given right here. We're going to try to keep the orders the same. So I can start again with the president as Abigail. And if I could do Abigail, I could do Bailey alongside. And I'm putting it third, right? I'm leaving a gap between them. So it could be Abigail and Bailey. But any of the other four remaining people could go in between them, correct? So I have Abigail and Bailey with, going them in order, I have Nate.
No.
Is that first?
No, it's girl, boy, or girl. Because president and treasurer have to be women.
Right. So here's what I was going to list. I was going to do like this. Right? So I've got Abigail and Bailey, the two girls on the ends of those two, and I'm going to switch out the people in the middle. Is that okay? Yeah? Okay. So I put Nate, David, Elias, and then I actually can put the third girl, Macy, in the middle as well. And this is the only way I can do Abigail and Bailey like this. But I could also just switch Abigail and Bailey, right? And it would create another four that look just like this, but the A and the B switch. So I can do B and A, BDA, BEA, and BMA. And those are all the groupings with Abigail in either of the outer positions and Bailey in either of the outer positions grouped together, right? But I didn't have to choose Abigail and Bailey. I could have chosen Abigail and Macy or Bailey and Macy, yeah? So I'm going to create these same, this is 8 of them, right? I'm going to create these same 8 groupings, but I'm going to switch out my outside characters, which is going to adjust the inside as well. So I'm going to keep Abigail the same for now, and I'm going to switch it to Macy at the end. So AM on each of these, like so. And we'll go through our list of others that aren't listed. So I have Nate. Actually, I'll do Bailey first since she's listed first. Bailey, doesn't matter the order. Nate, David, and Elias. And I can do this same grouping and then flipped over here, right? Just like I did with Abigail and Bailey. So I can do MBA. That's a degree, by the way. MNA. MD, whoops, DA. And MEA. Okay, so that's putting Abigail and Bailey together with the first one, Abigail and Macy together with the second grouping I just did, and then who do I need? Bailey and Macy in much the same way, right? So we'll do Bailey first and Macy second. And then we'll swap them in a sec. So we'll go through our list. Abigail's first, Nate's second, David's third, and Elias is fourth. I'm going to shift my number or letters all over for a sec. Capture everything. And then the last one is MAB, MNB, MDB, and MEB. Got a lot. That was more than the last one. How many did I get this time? Yeah, there are 24 on this one. Okay, we're going to change the scenario a little bit. The scenario here wants us to put 2 people, much like part 1 did, or question number 1 did. But it's just a committee. What that means is that, for example, over here when I did on this first one, AN, and then somewhere else I had NA, there's no need for that. That's the same committee. Okay? So when you get to the committee questions, those are actually easier to do because there's no requiring you to flip things around. That's nice. Okay, it's gonna result in fewer things to write down, and so it's really gonna result in. But then this one simply says to people, and there's no other descriptors. Like the others all had other pieces that were in there, and this one does not. So I can group any two people together to make this particular committee. So we're just gonna start with Abigail and find out all the people she can be grouped with. So Abigail could be grouped with Bailey, Nate, David, Elias, or Macy. And these are all the committees that Abigail could be on. None other. I don't need to switch anything else around. And what it means at this point is that I'm not writing any more A's down. I'm done with A's. So I'm going to go to the next letter, which happens to be a B. I'm not going to put the B with the A, because I already said I'm not writing any more A's down, so I'm going to group B with everybody else. So that would be B and N, B and D, B and E, and B and M. And while it feels like there's fewer, it's only because I've already listed another one that had B in it before, right? B's in just as many committees listed on the screen right now as A is. It's just that they overlap on that top one in the first list. Now I don't get to write any B's in again because B is listed in with every single person already once. So we're going to do the same thing again with the next letter, which is N. So I don't do NA and I don't do NB because they're already listed, but I will do ND and NE and NM. And now I'm done with Nate. Now moving on to David, and I need to list David and Elias and David and Macy. And notice I'm doing this in such a way that I'm creating kind of a triangle shape, right? And it makes sense because I'm eliminating one from the previous list every time. So having that pattern there is actually a help to us to remember we capture everything. We got everybody. So our last one then is going to be Elias and Macy. I think we got everybody. Does that look right? Great. How many did we get this time? 15. I promise we're going to come back to talk about these numbers, but it's not going to be in this lesson, okay? So there's 15 of them. We just count them when we're done. So what do these look like inside of my math lab? Well, sometimes they look like lists where they ask you how many, and then you look at multiple choice lists and you pick which one matches. It just depends on the particular problem, but you're doing some kind of a listing method. And it doesn't necessarily have to be people and committees. It could be letters drawn out of a hat. It could be numbers in a lottery. I mean, there could be lots of connections for this material, but that's what we're working with, okay? All right, taking a look at the next one, we're going to roll a 6-sided die, 2 of them actually. And what we're going to do is we're going to create a table of summations for the die. So there's other ways you could do this, but I really just care what the sum is. So I'm going to create my table to look something like this. And I'm going to list all the outcomes of each die along the top and along the left. So the die could be a 1, 2, 3, 4, 5, or 6. And then I'm going to do the same thing along the left. 1, 2, 3, 4, 5, 6. Okay, so far so good? There's just the outcomes of a single die. And this allows me to compare each of the outcomes at the same time. So what I'm going to do is whatever row and column I'm on, I'm going to add things together. So in this first location, namely right here, oh, that didn't show up as well as I'd hoped. Let's try something lighter. We're just doing white. Oh my goodness. It's still not showing up. Okay, we're going to do it this way. There, it'll work. Forget the highlighter. Okay. That spot right there is going to be in row 1 and column 1. So I'm adding the 1 and the 1 together, and I'm getting the result of 2. So in that location, I have a 2. When I move on to here, I'm in row 1 and column 2. I've rolled a 1 on one dice, a 2 on the other dice, and so I would add that result to give me a 3. We're just going to go straight across the row. What's going to be the next one? 4, and then 5, and 7. And once you get started on a row, that just adds 1 each time, right? And it'll happen the same thing on our next row. So our next row here has a 2 and a 1, so this result is going to be a 3. And then I'm on row 2, column 2, so I have the result of a 4. And the next one's going to be a 5. And then 6, 7, and 8. Row 3. Can you fill it in? Tell me what it's going to say. Okay, and now take a look at the columns themselves. They're doing the same thing, aren't they? Yeah, so column number 1 here goes 2, 3, 4. You can tell me what comes next. It's 5, 6, 7, right? So we can fill it in either vertically or we can fill it in horizontally. So go ahead and fill yours in. In fact, many of you already have, and I will as well. Okay, I messed something up. What did I mess up? Skip to 10. That's what happens when you're going too fast. Good grief. 9. Just going to do it one at a time. All right, there we go. All right, does yours look like that? Wonderful. Okay, so you're going to use that as we're taking a look at the next 5 questions or something like that. Okay, so our questions are going to ask us about this particular table. So having that table drawn is super helpful so that we don't have to keep counting every time. We can just go back to the table and we can find the items it mentions. So take a look at the table and determine the number of ways that you can get a 4. So how many 4s do you see in your table? There's 3 of them. You can read it right off the table, right? Now, if you had to list them out, could you? You could, probably from your knowledge about rolling dice, but also from this table, right? So the 4s themselves are along this diagonal here, and they represent each of the rolls that I could have drawn. I could have done a 1 and a 3. I could have done a 2 and a 2. I could have done a 3 and a 1. So I could list them out if I was asked to do that too. Even though the table itself has it all in sort of this compact form, we could expand it out if we needed to, right? Yeah. How about the next one, an 11? There are 2 ways to get an 11. What were they? 6 and 5 and 5 and 6, right? And those are different rolls. Think about the dice if it helps you as being sort of different colors. You got a red dice and you got a white dice, right? So when you're rolling them, you could actually see which one shows up which way. How about an odd number? That one's a little harder. You actually have to count. How many of them are odd numbers? 18. Did we get 18, everyone? Yeah, it's 18. So if there's 18 odd, do you know how many even there are? Though it doesn't ask. There's 18 as well. How can I know, looking at this table, how many results there are in general?
6 times 6.
It's 6 times 6, right? There's 6 rows and there's 6 columns. So the outcomes inside of my table, there's 36 outcomes. Makes sense that half of them would be even, half would be odd. And then we have between 6 and 15. I mentioned the word between because I want to make sure that you understand that between means we don't include 6 and 15. I also mentioned the 15 because obviously there's no 15 on the table. So I'm not going to look at it and find any 14s or 13s, right? But you can still ask for those values without them ever showing up, right? So when it says between 6 and 15, it really means 7, 8, 9, 10, 11, and 12, right? So this is 7, 8, 9, 10, 11, and 12 that we're looking for. So going back to your table, counting, how many of those, 7 through 12, are on our table?
21.
There are 21 of them, yeah. Multiples. Do you remember what the word multiples means? This is multiples of 3. 3 times something. So 3 times 1 would be 3. 3 times 2 would be 6. 3 times 3 is, and 3 times 4 is 12, and now I've got two values that are too large for my table. You can also think of it, instead of being 3 times something, as numbers that are divisible by 3. That's an equivalent description. So these are the ones that satisfy that description that are also in our table. So if you were going to go back and take a look at 3s, 6, 9, and 12, how many of them are there?
13?
There's 12. Check again. There should be 12. Did we get 12? Excellent. So there are 12 multiples of 3. So your problems will not all be dice problems, and they will not all be people problems, but they'll have the same kind of a feel to them as you're working on them in MyMathLab. Remember, if you are struggling with the context, you can always send me an email through the Canvas system, right? I didn't mean Canvas, through the MyMathLab system. That's the one I wanted. And so that you can ask a question like, I don't understand the context, or what does it mean by this? Please do that so that I can give you some feedback if you do have any questions.